I guess I can do a quick intro while we're waiting. Uh, Hi, I'm Pradyun. This has been a fairly packed event over the last few days, and as you can hopefully infer from the title, this is a somewhat different topic to all of the talks we've had so far, which have mostly focused on the tooling and how to use them and how they operate. This one's more closely to how it's developed and tested.
Yeah, your screen was shifting a bit for the presentation, but now I think it stopped. So you're good.
Okay, interesting. Another minute.
So much tension.
So yeah, great for the nerves.
So let's do a mini interview. What do you think about Packaging Co? Are you enjoying it?
I am enjoying this a lot. It's been super interesting to have all of these folks in some senses the same room, and have there have been some really interesting conversations that have happened in, well, the text channels that we've had, as well as Gather the Town, which is where we're sort of doing this hallway-ish, track-ish thing. Yeah, pretty cool. Quite happy with how it's turned out so far, and especially happy with how well it's gone for a first time event.
Yeah, I must say that for me it was a bit overwhelming because I wasn't used to 4 parallel tracks anymore.
Yeah,
Like online conferences past year tended to be more one track and you stick around. So I'll have to go back and watch a lot of talks later.
likewise. Well, one of the benefits of an online conference, it's all online.
Yep.
Cool. I guess we'll get started. I guess.
Yeah, let's go.
Said I
So
guess too many times there.
I'll be getting out of the way. Bye bye.
Thanks for that, Louise. And hello, everyone. I think that should be everyone here by now. So, a very quick introduction for myself to note things that might be relevant to the audience at this event. I maintain various components of the Python packaging ecosystem, volunteer to moderate on PyPI, not PyPy, PyPI, maintain a few things related to Sphinx, which is a documentation tool, maintain the tonal specification, which we've heard a bunch of today. And as part of my day job, I work on Bloomberg's Python infrastructure team. With that out of the way, let's dive right in by talking about what all to care when you have a large and decently complicated test suite. And this is in no particular order. The total runtime matters because that affects what your workflow is. 30 seconds is very different from 30 minutes, especially if it's for your test suite or if it's for your CI. I have projects that take 30 seconds for a CI run, and that's very different from how I'd operate for pip, which does not have a 30-second CI run. Isolation is useful for enabling parallelism and is generally a good idea for tests anyway, so that they do the right thing. You don't want tests to be too difficult to write because then you start being lazy and lax about them, which is suboptimal. Often it's difficult to write these difficult to write tests become difficult to maintain tests, and you don't want that either. And having a big CI matrix makes all of these things complicated. All of this also feeds into where your bottlenecks are in the developer experience. Your CPU and SSD have a limit, your CI platform has limits, you have limits on how much your free time there is. So you need to be mindful of all of these resource limits or bottlenecks. And to start to make all of that wishy-washy stuff more concrete, for pip, we have a fully parallel test suite. More on how we achieve that later. Uh, we try to parallelize as much as possible because it's slow, and through some very targeted profiling and changing things to see what happened, we found that our tests are largely IO bound, not network IO, disk IO. And that's why we use a RAM disk in CI. With the reason that Windows VMs images for GitHub Actions and Azure pipelines have like a utility installed that's needed to make RAM disks. And despite that, we still have significant differences across platforms. Windows still takes a lot more time than Linux because of OS specific overheads that we don't have time to discuss here. A lot of the choices that I'm going to talk about here are trade offs we've made, largely constrained by volunteer availability of developers. On the isolation front, well, this is where we get a lot of the overhead I mentioned earlier. Each test gets a full virtual end for isolated installations. And we do a bunch of additional stuff to make other tools, like Git, behave in a way that provides more isolation from the user's environment. I like having my configuration files not changed by the fact that I ran tests. And all of this brings with it some decent amount of complexity because you need a bunch of logic to do the right things here and clean up after it. And we deal with that complexity using a feature from our test framework, PyTest fixtures. Turns out it's a good idea to lean into well designed features for the thing you're doing. All of the logic for handling the home directory, configuration, cache isolation stuff happens in the isolate fixture. Virtual environments, they're created by the virtual env fixture. And the script fixture brings all of this together in a sensible interface that makes running things easier. One of the things that this lets us do is make blanket improvements. We got like a 20% speed up by factoring out the repeated bits of work that some of these fixtures were doing into a single place, such that it's reusable. And yeah, things are now 20% faster. These are some examples. We have a lot of fixtures like this that do a lot of stuff. And that complexity we still have fairly readable tests, I think. Uh, I hope you're able to read this test and at least understand the intent of it. Um, there are abstractions. They hide some of the complexity here. But this test is, well, it clearly and directly expresses what needs to be done, what's happening, and when there's an error, it can present error messages with details from these higher level primitives that we've built, which is quite great. And things run on a subprocess, which very closely models how our actual users use pip. And we don't need to deal with shared in memory state that needs to be cleaned up after a test run. And there's no easy way to modify what the code does outside of the inputs you give it, which is exactly how the user interacts with pip. And this gives us confidence that pip is doing the right things and that the tests are indeed testing what they're saying and that they are indeed isolated. And well, we can parallelize them, which is also great. This is also quite painful because things run in a subprocess. Failures, well, they can be opaque and difficult to understand because it's hidden behind it's hidden behind a subprocess. And you need the test scaffold that you've built to have information about, hey, how can things fail? So that you get a reasonable error message, or you need to learn the quirky error messages that you get out of it. Or and the fact that you can't attach a debugger easily. It's a subprocess spawned by a test running in a subprocess spawned by the test framework because we're running with parallel subprocesses in the test framework. Yeah, it's not fun to try to attach a debugger, and that makes things more complicated. This also means we have to do additional shenanigans for tracking coverage. And we have it all piped up, but it doesn't cover all the weird ways that we run our tests. So we don't really have reliable coverage metrics because of how we do things. And as I mentioned, these abstractions hide a lot of complexity and overhead. And well, this overhead is slow. It causes things to be slow. It is also extremely easy for us to hit the network, which, because of how pip works and because of how our CLI testing works, which is not great. And these multiple layers of attraction, as I said, make it difficult to maintain in some senses. And, well, All of this is something we want to improve, is what I want to get at. But we've made slow to no progress here. More on that in a bit. Talking of slowness, though, let's talk about CI matrix sizes. Ours is big. As I'm sure lots of folks here are familiar with, if it compiles, it runs is a mentality that a lot of people take. We have clear policies around what we support, and there's still a lot on that front. For example, we don't cover patch versions of Python other than the latest one, at least on a best effort basis. We don't cover BSD or less popular platforms. We don't cover certain architectures, but I'm sure people run with or pip on all of those platforms in all of those situations. We can't test for that because that is combinational explosion that we don't want to deal with. Now, we used to have fuller coverage than we do right now. That's because of our CI provider story, and yeah, I'm getting ahead of myself. For what we've done so far is we've kind of reduced the dimensions of our CI matrix. Downstream distributors, we saw Fedora, we've had Debian mentioned a few times. Well, they're in the best position to ensure that if they're debundling pip, it actually works. Especially since they might want to have additional patches, and that can also change things. And through the efforts of many folks, we took the component that had all the OS specific logic and moved it into a separate library. And that significantly reduced the need to like run a test suite, entire test suite across various architectures. And yeah, we reduce the dimensions wherever possible. So Windows tests are slow. We only do boundary checks there. And in line with some of this, we have been early adopters of CI platforms. I looked this up for this slide, and we adopted the latter two, GitHub Actions and Azure Pipelines, in the same month as they got released publicly. And Travis CI was the first time we had CI, as far as I know. So, yeah, fairly early adopters. And each of our newer providers brought benefits to our workflows. And as you might notice, this slide does not have the word removed in it. That's because we ended up with a multi provider CI setup so that we had as much coverage of our CI matrix as possible. I forgot my word there. And while this multi provider setup had a lot of benefits, mainly the increased CI resources that we had available, it also brought a bunch of challenges. We now needed to know how to configure, maintain, and understand three separate CI platforms. And we were affected by outages on all three of them, as well as any changes that they'd make. And at best, these would be announced in a blog post that we'd have to check every few whatever days, weeks, and or it's an unannounced change. And we only see that when stuff starts breaking. Other than that, we also have to deal with the fact that each of these CI providers do things differently. Newer software comes a little later than you'd like. Like the latest Python release or development releases of Python, which you'd probably want to test pip with. And as we learned with Travis CI, we're also kind of vulnerable to changes that they may make on a revenue front model front. And yeah, yeah, no more on that. So one fine evening, more like late night, uh, I ended up working on removing all of our actual CI stuff and moving to a single provider. You can sort of see the RAM disk line here as well. Um, Mainly to reduce all the pains that I just discussed about having a multi-provider CI setup. And there's only so much time we have as volunteers to maintain multiple CI pipelines, and yeah, maintaining multiple CI pipelines isn't the most fun thing to do either. So GitHub Actions is our single point of failure now. It's a double-edged sword. On the one hand, it's the most popular platform, at least for now, and outages are rare and fairly short when they do happen. On the other hand, they are fairly crippling because now all of our CI setup is gone. We've also brought this into a bit of our workflow stuff. So that sucks as well. But hey, it's also our quickest CI platform. And well, it was our quickest CI platform, which has carried over. Our CI times on average are faster. It is also the provider with the fastest availability of Python versions, which is kind of important for us. And as it turns out, it was the easiest provider to maintain of the three we had, especially after Travis's revenue model changes. And well, I guess that brings me nicely to talking about our current setup. And here's how we model it. Uh, Use all the parallelism that we can. Make use of every single resource that we can. Maximize how many workers we've got. Uh, hey, we have a bunch of RAM. Let's have a RAM disk. Oh, we can make it bigger than it used to be. Great. Uh, which is great. And we don't run. We try to short circuit our CI runs as much as possible. Uh, well, because tests take a while. And if a quick check fails, you don't need to do a more resource intensive check. And you don't need to check things that haven't been modified, which, well, pictures, because they're worth 1,000 words. We check what's changed, and if we've had any change to code we vendor, that's a separate conversation. Our policy is defined somewhere. Well, we don't touch that vendoring check until you modify the vendor files, which is great. Now, that check became a lot faster because I spent a bunch of time on that a few days ago. So I'm pretty happy with that, and I might just move that to an unconditional pre stage. And as I was saying, pre stage, which is the pre commit and packaging one, that is doing sanity checks to make sure that, hey, things work properly. And we have a separate docs check because we want to make sure we get documentation breakage early in case the links break or whatever. And if you're somehow curious about how long things actually take, it's not that bad given the amount of parallel workers we end up using. Uh, you might notice that the Windows workers still take twice as long, and they're split across two workers. There's two workers doing this CI test runs, half half, and they both have RAM disks, and the Linux and macOS ones don't. Uh, it's fascinating. And that's it. Questions? I went faster than I planned.
We do have questions.
Ooh.
So let's bring the question up. How did you become confident that you didn't need multi-platform testing for PIP when things moved to packaging?
Well, we do have multi platform testing. We just don't have as fine grained tests as we used to. Mainly because most of script is fairly platform agnostic. It's a Python script, and well, the only bit that we really care about from the platform is in the chunk that we moved into packaging, which was, hey, what's the platform architecture? Hey, what's the platform glibc version and all of that fun stuff. All of that moved into packaging, and it's fairly extensively tested there. And it also becomes reusable for other tools. So we know that is sort of getting battle tested a lot more than it used to in RCI anyway. It was still battle tested code for sure. But yeah, that was part of how.
There was a question about if is there value on having something like dependabot or something that intersects between running various CI providers to have instead of like something that would well, let me read it properly. Is there value in a shared abstraction over the various CI providers? Something like a dependabot, except it sends you a PR to switch from Travis to GitHub or whatever.
I mean, Dependabot is most useful for monitoring. I guess this is about automated PRs to do stuff. Uh, I don't think there's going to be any easy way to automate migrating CI providers, if that's the
Yeah.
question.
I
But
personally never had any good experience like having something automatic there so much. so many things
Yeah,
that you need to
I
debug.
don't think most of that is automatable.
But then someone
I
also
don't think.
suggested something like Conda Smithy, the thing that the Conda Forge people use to switch from providers.
Yes. Theoretically, we can also switch providers fairly easily. That was one of the things I wanted to make sure we don't do, which is tie ourselves too closely to a provider. Um, to that end, we also sort of want nicer CI platforms to exist than just GitHub Actions so that we don't have a single point of failure. But that's way beyond the scope of effort I can put in.
Fair enough. Another question. For your personal workflow, do you cut some corners for prototyping?
Yes. Isn't that in some senses definitionally what you do in prototyping? Yep, for sure. The goal of prototyping for me anyway is to make sure you have something that mostly works and proves that it is feasible to do this properly. Uh, Now, the conversation about how things that sort of work are put into spaces that they're not supposed to is a different one.
Do we have any more questions? I don't see any other questions on Element, but you're also around on Element, so if people want to ask any more questions,
Yes,
and answer
I
over
will
there.
probably end up being in the gather room, whatever, gather the town rooms, because it would be nice to hang out with people.
Yep.
So if you want to catch me and sort of talk dependency resolvers or pip or Python packaging or Tomo or documentation, basically most things, I'll be happy to.